Okay, chemistry nerds, here's the practice exam video, but I gotta give you a warning before you watch. Here on this document, the answers have already been marked. So I highly suggest you complete the practice exam first before watching this video, because this video is just gonna give the explanations to the answers along with some notes and scratch work that might be helpful. Okay, so let's begin. All right, so as you can see, the answers have been marked up as I warned previously. And so let's start with number 1. So here's the chemical reaction for the production of ammonia. And this question is asking about the formation of ammonia being favored. So we're producing ammonia. That's what we're looking for. So we should be shifting to the right. We should look at each of these choices that show a shift to the right. And I'm going to explain why answer A is the correct answer. And looking at this, pressure focuses on the gases. So we have 1 and 3, that's 4 moles of gas here. And on the other side, we have 2 moles of gas. By increasing the pressure, you want to move away from the high pressure side, going to the lower pressure side, which is the right. So that's why we're shifting to the right side. The other 3 choices show a shift to the left. Okay. Number 2, which arrow represents the activation energy of the forward reaction? That means we're going from left to right. So the activation energy is we start where we are here with the reactants, going all the way up to the activated complex. That difference here, interval B, is the activation energy. If you're interested in the others, A is the heat of the reactants, D is for the products, and C is the heat or energy of the activated complex. The activation energy is different from the activated complex. Number 3, at equilibrium, the concentration must always be constant. That's the key word, constant concentrations for equilibrium. Equal, that's not correct. That's only for reaction rates. Equal reaction rates. Okay, number 4. In terms of energy and entropy, so energy is going to be delta H. Systems in nature tend to undergo changes toward lower energy and higher entropy. High entropy meaning high disorder, so that leads to a lot of collisions. If you have a lot of randomly dispersed particles, that means they're most likely going to collide with each other and favor high, fast reactions. As low energy, that's exothermic reactions, those are also favored. All right, 5. Which statement best explains the role of a catalyst? So what is the main purpose of a catalyst? Basically, dealing with activation energy. It lowers activation energy and speeds up reaction. That's the main key point. Number 6 ties into the collision theory, and basically effective collisions is the main idea of it. You need to have effective collisions for reactions to occur. Number 7. We're looking for traits of equilibrium. And looking back at number 3, concentrations have to be the same. And if you look at C and D, those are incorrect because they talk about different concentration values or being equal. But how about the reaction rates? They have to be equal. That's why choice A is our answer. Okay, number 8, given the potential energy diagram for a chemical reaction right here, which statement correctly describes the energy changes that occur in the forward reaction? We're going from left to right. So our activation energy is right here. The difference between 40 and 50, that's 10. So we could cross off C and D. And the fact that we end with a lower energy for the product side, we're releasing energy, therefore it's exothermic. If this thing were higher up here, then it would be endothermic. Okay, number 9. The equilibrium point will shift to the right if the pressure is, so let's focus on pressure first. We need to go to the right. On this left side, we have 3 moles of gas, and over here we have 2 moles of gas on the right side. So why would we shift to the right? Why would we want to go to the lower pressure side? That means we had high pressure. Pressure was increased. So we want to go to the lower side. We want to move away from the high pressure. Now, what about temperature? By going towards the heat right here, by going towards the heat, that means we must be cold. We lost some heat, we lost lower temperature. That's why that's why the answer is choice B. So based on pressure, you could cross off C and D. Now between A and B, we had to focus on the fact that we're moving towards the heat. That means heat was lost, temperature was decreased. That's why it's choice B. Remember keywords, if you increase or add something, then you want to move away from it to get rid of it. Whereas if you took away something or decreased it, you want to move towards it in order to put it back. Okay, number 10. Here, what is the approximate delta H for the formation of 1 mole of H2O liquid? Okay, so we need 1 mole. In our reaction here, we have 2 moles. So we need to half this. This is our delta H value, 571.6. Not positive. Let's focus on that fact later. So 571.6 kilojoules divided by 2 will get us, well, 285.8 kilojoules. Now, why is it a negative value of the answer? Look here. We have energy on the product side, so we released energy. Versus if it were on the other side, that means you absorbed energy to have the reaction. But since energy was a product, you released it. That's why it's negative and exothermic. Number 11, as the number of effective collisions increases, the rate of reaction increases. That you just have to know. Number 12, which statement must be true when solution equilibrium occurs? The concentration of the solution remains constant. It's a repeat of number 3, kinda. Number 13, so here our answer choice is actually C. So the purpose of the catalyst is not only to lower activation energy, it's to also increase and speed up rate of reactions. And it increases both forward and reverse equally. Number 14, we want higher entropy, so more disorder and randomness. And looking at our phase changes here, A, B, C, and D, B is the only one that goes from liquid to gas or to a more random state. The others go to a more orderly state. Number 15. So, we're focusing on the moles of HCl after you add O2. So O2, we're adding this. It's up here. So because we added this, we want to get rid of the extras by moving away. So we're going to the left, shifting to the left. Because we're shifting to the left, not only are we getting rid of this, we're also getting rid of this. So that's why the number of moles of HCl will decrease. 16, which has the least entropy, so what's already in here, lower temperature equals more organization, as well as looking at the state of matter, solid phase. So it's not only the lowest temperature, it's also the most orderly phase, the solid phase. 17, you kind of need to use the reference table, but a key word here to know which one you're looking for. Which salt releases energy? So it's exo, which means a negative delta H. So you're looking for the one that has the negative value, and the only one that has that is choice B. Number 18. So it's saying that each of these here is equal to 40. Each interval is 40. So here we're looking for the heat of reaction, here to here. So we start from 120, products minus reactants. 120 minus 80 is 40, positive 40, especially since we have an endothermic reaction because our product state is higher than the reactant state. Number 19, which change is exothermic? Okay, so we are looking for something that releases heat, and thinking back to our state of matters or phases of matter lesson, freezing of water is the only one that is exothermic, going to a colder, lower temperature, releasing heat, whereas the other ones are going to higher temperatures, you're heating up, therefore you need to absorb heat. Number 20, which trial would produce the fastest reaction? it would be choice D, why? Because let's see here. Let's focus on concentrations and temperature. Trial D has the highest concentration, which means faster reactions, more collisions, and highest temperature, more collisions, faster reaction. Okay, so we need to draw the potential energy diagram, how it will change when a catalyst is added. So the purpose of the catalyst is to lower activation energy. So the activation energy is from here to here. So we just need to show a lowered amount, going from here to here. That's all you need to do. And it's the same thing for the reverse reaction. For the reverse reaction, you're starting here and going all the way up here. And so you have to lower it by going from here to here. Still being lowered. Okay. Number 22. Explain in terms of collision theory. So you just need to mention collisions in your answer. Why increasing the pressure will increase the rate. So as stated here, increasing pressure leads to more collisions. So faster reaction rate for the forward direction. Okay, so 23 and 24 is a follow-up. We need this reaction that I copied over from the previous page. So state in terms of concentration of SO3. What occurs when we add more O2? So when we add O2, we want to move away to get rid of it, going to the right side. Shifting to the right, so by going to the right, we create more SO3. That's why it increases. Number 24, determine the amount of heat released by the production of 1 mole of SO3. So based on this answer, here, because we're releasing it, it's a product energy, so it has to be a negative value. So delta H is negative 392 for 2 moles of SO3. You need 1 mole, so therefore you have to have it to get negative 196 kilojoules. Now we are on the last page. So we have to answer numbers 25 to 27 based on this equation. So what piece of information here indicates the reaction is exothermic? So as stated in the answer, heat is a product. It's on this side, so it's being released. Number 26, why the entropy of the system decreases as the reaction proceeds. So hydrogen gas and oxygen gas turn into liquid water. Here we start with gases. They're very random, and it goes to a little bit more structure in the liquid phase. So that's why entropy decreases. And because it's exothermic, you just got to draw this whole loopy thingy, and you should get our product side to be lower than our reactant side. And voila, we finish. And now Mapoy is in the mood for tacos. When I get home, I'm probably going to order some tacos for dinner.